Securing Kubernetes on AWS by Csaba Szegedi and ChatGPT. In the land where clouds arose, a tale unfolds. A developer squad and a security crew so bold, a realm transformed by the public cloud's embrace. On-prem city left behind a new frontier to chase. These pioneers discovered magic in the air, where tasks were swift and burdens they don't bear. To the cloud they flocked, with tools in hand, a new world for developer, a promised land. One developer dreamt of a system so grand, to orchestrate containers, in harmony they stand. Kubernetes, his vision, reborn in the cloud, elastic Kubernetes services, a miracle evolved. Developers rejoiced, their creation now thrived, but the security crew, their fears undenied. With K8s embraced, they foresaw a storm, so they fortified defense, a fortress they'd form. The security crew, with vigilance in mind, devised a plan, K8s, to safeguard and bind. In private networks, they cloaked its glow with firewalls, access control list, a fortress to show. Route tables were crafted as part of their scheme, but in their fervor, an unintended thief. Developers' access now severed, dismayed, a gulf between factions, a heavy price paid. The developer squad rallied, resistance they tried, walkout, guerrilla actions, identities they'd hide. Yet the security crew's defense remained tall, K8s a treasure lost, hope seemed to fall. In the shadows of despair a spark emerged, collaboration the key, as the past converged. United they sought a resolution to find, a way to mend the rift and lift discord behind. With common ground they formed a truce anew, session manager, RBAC, and IAM, a capable crew. Together they approached the High Council with grace, seeking an approved path, a solution to embrace. The High Council, moved by their earnest plea, granted them access, a door opened with a KMS key. Security measures upheld, yet access restored, a testament to teamwork, their victory assured. K8s within reach, developers sang in glee, containers ran in harmony, a sight to see. Through collaboration, they triumphed and learned that unity and trust were the rewards they earned. And so our story, a legacy it leaves, in the land of clouds where dreams interweave. Let us remember a history unfold, a developer squad and a security crew, so bold. And so concludes the tale of elastic Kubernetes services. But before going into the details of this story to see what's behind this story, let me just say thank you to my colleagues who took part of this comic. So thank you, colleagues. Thank you, Madhu, for playing the role of elastic Kubernetes services. And yes, that's me, Csaba Szegedi, a solution architect, an AWS solution architect at Deutsche Telekom. I also work as an authorized AWS instructor. I'm a fresh community builder. And yeah, in the past, I worked several years, 10 plus years as a developer. So yeah, I know the feeling more from developer sides when the regulations, the security requirements need some extra efforts to make solutions more secure. But let's see this story, which happened with me. I was working with Elastic Kubernetes services with a system team, and we had to provide a solution so the developers who were cut away from EKS because we had to make Elastic Kubernetes services a private cluster, not published on the internet, how we solve this problem. First of all, let's see what is EKS, what's behind EKS, and what is a public EKS endpoint, and why we need to make this EKS with public endpoint to an EKS with private endpoint. Okay, so behind EKS, there is a Kubernetes cluster. When you deploy Kubernetes, you deploy a control plane, some worker nodes. The applications deployed by developers will be running on these worker nodes. The communication between the control plane, which is managing the cluster, is done via the API server. These kubelets connect to APIs and make sure that each container will run in a pod in Kubernetes. So this Kubernetes is something which is a solution, open source solution, a really strong community built around it, and yeah, it is possible to deploy on many different platforms. If we use EKS, then we deploy it on AWS, the one of the cloud providers. So the communication with cloud providers goes via the Cloud Control Manager. Okay, our main focus will be on the API server, because actually that's the thing which is made either public or private, and that's the main communication point between the worker nodes and the control plane, and also between developers and developer tools like command line interfaces with kubectl or Lens as an IDE. The management or deployment of the APIs, of the services, will be done using these tools via the Kubernetes API. Okay. Now, EKS manages lots of things for us instead of us. So the control plane is fully managed by EKS, highly available solution. The worker nodes can also be created by AWS tools, or actually will be created by tools provided by AWS, either by web tools like from the management console. You can create clusters. You can use the EKS command line interface. You can use CDK, SDKs, and other infrastructure as a code. Let's just say some third-party tools like Terraform, Pulumi. So these tools can help you to quickly deploy an Elastic Kubernetes services in AWS. So again, after the cluster is deployed, communication channels are open. By default, if you deploy an EKS cluster, public endpoint is created for the API server. So kubectl communicates via that. Worker nodes communicates via the API server on this public endpoint. There are some private endpoints also, but not private. So this icon here shows Elastic Network Interface. So some communication also goes there with the EKS, but even in case if you create only a public endpoint solution. Okay, so once again, Elastic Kubernetes Services is a managed service that runs Kubernetes on AWS. without the need to install, operate on or maintain your Kubernetes control plane or nodes. That is done by AWS for you. Makes it highly available across multiple availability zones. So it will reduce lots of burden from your shoulders. But okay, endpoint, which is public, how we can secure that. Of course, having a public endpoint, it's not that anybody can access your cluster. But yeah, you can imagine your endpoint is publicly available on the internet. If anyone gets access to one of your user credentials, will have access to your cluster. No other means will stop that somebody to access your cluster. Okay, but nevertheless, identity and access management and Kubernetes role-based access control, or RBAC, can secure your APIs. You can also restrict IP address ranges who have access to your public endpoint. So these two tools can help you to defend your endpoint, which is public, and kubectl is accessing that. I don't know, the developer from his own machine, from his home office. Then yeah, the worker nodes will also communicate via these endpoints. Okay, the defense with IAM and RBAC goes as the following. So kubectl, the developer from his machine tries to access the Kubernetes API with the kubectl command. It needs to pass the AWS identity, which he been provided. Kubernetes API will communicate with AWS via the Cloud Control Manager, will send these identities to IAM. IAM will authenticate this role, for example, which was used by this user. And if that's a valid role which this developer is using, then Kubernetes API will contact the RBAC and will check if this user is authorized to do the requested actions. Okay, if that's allowed, then the user will be provided with access, and the command will be executed successfully. Okay, so this is the default way of deploying Elastic Kubernetes services. And yeah, let me show you how you can do that with CDK, the AWS Cloud Development Kit. As you can see, it's not a big deal. Not too much configuration you are doing. So this code snippet which I just selected, that's the code which will create an EKS cluster for you when this CDK will be deployed. So I'm just specifying a version here. Actually, this default capacity is not even needed because the cluster can be created without worker nodes by default. But here I want one node group where my worker node will be deployed. So this default capacity says that. I also specify a smaller instance for my test cluster. I don't want to that my cluster is created with a large instance, just for cost, to reduce cost for my cluster. Okay, so I'm using a T3 medium instance in this case, and yeah, the endpoint access is public. That's the default attribute, by the way, so that you can just create a cluster with Kubernetes version, and that's all. And yeah, with that, let's just move to the management console. A public cluster was created. This is the EKS dashboard from the management console. You see, yeah, the resources are prepared for the workloads, pods, replica sets, stateful sets will be accessible also from this dashboard, or I can access it locally from my Lens IDE. I will show you that one soon also. But okay, so I have this cluster. Let's see how to access that cluster. Okay, first of all, I will use kubectl just to list the namespaces in that cluster. First, I just use the correct user. So I will use first a system master role in the cluster, which has administrator access in that cluster. I also have to update my kubeconfig using the EKS update kubeconfig of the AWS CLI command. I can simply specify which EKS cluster I want to register in my kubeconfig, and that will do for me and will update the kubeconfig file for me with the relevant certificate, authority data, server address, cluster name, and yeah, some user related data for my public cluster. And yeah, you see the public master profile, AWS profile is used right now. So I'm master in this Kubernetes. I can get namespaces. I can create namespaces. I can deploy to any of these namespaces. Okay, but yeah, when we don't want our developers to have administrator access into our Kubernetes, we can use these RBAC roles. For example, I have created an RBAC role for a user which has access only to one namespace, to this public namespace, which I already have been created. Now to move to that user, I have to switch to that profile, this public namespace profile, public NS profile. Is using this IAM role, which is called public NS access, EKS namespace access role, blah, blah, blah. This is an assumed role, but I also have to call this update kubeconfig command again. So my kubeconfig will be refreshed and this namespace to be used. Okay. In this case, if I just try to get the namespace, we'll see that it is not allowed. It will be denied for the EKS user. This is the EKS user as a role in RBAC created and bound to my IAM role. Okay, this is how the authentication and authorization happen. But yeah, I still have access to the public namespace. So to demonstrate that one to you, I will simply deploy this Hello Spring Boot application with kubectl apply -f deployment YAML and the namespace. I will specify that. Then, yes, so my application was deployed. If I would try to deploy to test2, that would be denied. I don't have access to that namespace. Okay, my application is deployed. I mentioned this Lens tool. This is an IDE which can be used to access Kubernetes clusters and also EKS clusters. So I have prepared the public cluster and later on the private cluster to which I can connect right now. So let's just connect to the public cluster. It will use the context which is configured in the kubectl. So this is the public namespace access. And unfortunately, in this case, the problem will be that I cannot see the namespaces because I don't have permission for that. So I will just disconnect in this case, and I will just go here, set back the public master access for by Kubernetes. Of course, there are better ways to do and switch between contexts, but I'm just doing with this profile switching between these different users. Okay, so namespaces, these are the namespaces. We can see the test and the public namespace. And if we go and check the deployment, we see that the hello world was deployed into the public namespace. It is running. So let's just find the service so we could also see what's really behind. So this is the hello world service. We can see all the resources which are related to this hello world, pods, replica sets, deployments. So hello world service. This should be the one, yes. And I need to take this endpoint from here. Now, what is this endpoint? Actually, behind of this, we have an elastic load balancer, which was also deployed by our cluster automatically. You remember the code, the amount of code which I wrote to create a public cluster. That was all. And this load balancer was created, and from my application client, I will be able to access this load balancer now. So I just grab that URL and hello from EKS with public endpoint. So this hello world application, the Spring Boot application, is just simply returning this value. So you would see that we are running a container from this public endpoint. So we can restrict our developers to have access only to a specific namespace. Okay, that was what you saw here with the with this public namespace access role. Okay, let's move back to our presentation and see how how can we secure our Elastic Kubernetes services by making its endpoint as private. Okay, so by creating these private endpoints, it means that we bring the API server the endpoint into our, for example, corporate network. And we will make access only from that corporate network environment. You can see that with this, we limit the access from external parties. That also happened with our external developers. So we needed some solution to solve this problem. But yeah, before seeing that solution, just quickly, let's have a look on the architectural diagram, how this private endpoint or the hybrid solution where you have both public and private access. So when you enable both accesses with an EKS, then the kubectl access from externals is still going through the internet. But the communication between the API server and the worker nodes is done only via the EKS-owned Elastic Network interface. A private hosted zone will be created in Route 53, and this private hosted zone will be resolved to private IP addresses. So internal communication will be happening on private channels. External communication with the from the developers from the Kubernetes clients will still be happening via the internet. Okay, if we have only private access enabled, then the communication will from the Kubernetes clients will also be done via this private hosted zone, and only from within internal networks can access our clusters, our API server. Okay, so all kind of different resources, networking resources, can be used to defend this or create this private network to secure this private network access control lists, so firewalls on subnet level, security groups, route tables. So yeah, we could create these networks so there wouldn't be even outbound internet connection from these worker nodes. It's a harder thing to implement. I will not show you that, because in that case you will also need VPC endpoints, communication with AWS resources, services will require these VPC endpoints. But yeah, maybe that's just another story. For the current demo, we will stay with outbound internet connection, so NAT gateway will still be available. For example, if we want to deploy some service from Docker Hub, that would be easier done, and we don't need to create our own container registry from where we can download and deploy these container images. Okay. Our Bastion host was implemented using EC2 instances. This Bastion host was defended with the security group as a firewall with 0 inbound ports allowed. We also provided an IAM role for this EC2 instance, which allowed all the application and all the command line commands executed on this Bastion host to go to AWS with this IAM instance profile or this IAM role. Okay, but if there are no ports allowed, how can we connect to these machines? The solution is using the session manager. By having the SSM agent running on this EC2 instance, we are able to connect to this agent via the systems manager, session manager service. Okay, so security group will not affect this. So whenever the user logs into this machine, we'll be able to access the Kubernetes API server using kubectl, and we'll have the permissions which is bound to that EC2 instance using the IAM instance profile. Okay. Now, in this case, what's happening, I will demonstrate that one, this use case. You will have, so the user has to use the AWS Management Console to access the session manager. I need my Management Console, so I have the Bastion host prepared. You can see that I have 3 instances running, these other two instances are the new node groups created for my K8s cluster. So if I just check the tag here of this instance, I can see that it was created for the private cluster, and this one was created for the public cluster. Doesn't matter that one right now, we will want to connect to the Bastion host. Now, this Bastion host is prepared with the SSM agent. So what I need to do here from the management console, click on the connect, select the session manager tab here, and connect to this instance. So I'm in the terminal window provided by the systems manager, session manager, and I already have kubectl installed on this machine. I can just execute kubectl command. But first of all, let's just check the role which is right now applied, just to see. AWS STS get caller identity. That is the command with which you can check the user roles which are you using right now. So there is an assumed role, Bastion role. This is the instance profile which is right now applied to this machine. Okay, so kubectl get namespace. This role has permissions to list these namespaces in this cluster. I have been provided that role. Let me just quickly show you that. I need to go to the IAM management console dashboard. I have it here in my recently visited pages. And let's just look for the Bastion role. You will see that this Bastion role, first of all, needs to have this SSM managed instance core AWS managed permission set to be attached. And I also have this describe cluster permission, which allows to describe resources in this cluster. Okay. Now, what's the problem of the developers with this solution? This is only a terminal window which they will receive. So Lens is not available. So maybe K8s as a command line solution is available, which, yeah, it's some sort of solution. And in our case, that will be the solution, because the solution which I will show you next, although makes or provides access to developers, it's not accepted by our security team, because with that solution, we cannot provide session logging for all use cases. For example, we cannot log those sessions which will exec into a pod, for example. Why is that a problem? Because after the developer execs into the pod, it's still inside of our network, our company network, but it's totally disappeared from our side. So whatever commands does from there, it's not visible. Using this solution with Session Manager, also those executions are recorded, are logged into our central bucket. Okay, but yeah, this is the solution which is taken by our team. The next step, which I'm showing to you, yeah, it's not so secure in the manner if you want to log all sessions or session commands happening in your Bastion host. Okay, now this solution is done with the Session Manager port forwarding solution. For this, you will need to download on the developer's machine a Session Manager plugin, which will run on your machine and will connect to the Session Manager agent. Okay, what's happening then from the Session Manager agent to the Kubernetes API, we also need there something. It's called the kubectl proxy. Kubectl proxy will be the proxy between the session manager agent and the Kubernetes API. So session manager plugin, session SSM agent, kubectl proxy, and then the Kubernetes APIs. And using this solution, then the developer can access private Elastic Kubernetes clusters from within their development environment, using Lens, using command line, whatever they require. Okay, so Lens can be also used. Okay, let me demonstrate this solution also. First of all, here in the session manager, we need the kubectl proxy to be running. Okay, this is listening on port 8001, waiting for connections. Next step is to start the session manager plugin. Okay, sorry for that. I need, for that, I need my instance ID because the session manager plugin will connect using as a target ID, the instance ID which I'm using. Okay, which window shall I choose? Yeah, I have one prepared. Yeah, let's just run it from here. I will use the demo user. That's an administrator user to run the SSM profile. I also have a command prepared for this demo. So SM, you will see how this is resolved to an AWS CLI command. So I have the instance ID, I need the remote port, and I need the local port where this will be listening. So SMPF session manager port forwarding is my command, which is calling the AWS SSM start session with the target instance ID, document name. That's the that's how SSM will know that we are doing a port forwarding now. Parameters, the port number, that's the remote port where that's listening, and the local port number. Okay, it's waiting for connections. Now, from here, wait a second. Let's just stop this session manager right now to first demonstrate that this connection is not working without this solution. So what do I need here? I'm configuring the private cluster. That's okay. And let's just call a get namespace command. You will see that it's trying and trying, and at some point there will be a timeout. We won't wait for that because yeah, it's a longer period. Wait a couple of more seconds, but I will terminate this struggling. So I will just terminate this, and let's just start the port forwarding session. Okay, what do you think? Will this work with this solution only? Let's see, get namespaces. It's still not working. Something is still required. Okay, there is a trick which we need to do in the kubeconfig. Right now, for this private cluster, the server name is this one. This is an Amazon AWS.com endpoint. That's not okay because our session manager plugin is listening on the local host. So we need to change that manually or using some kubectl command. That's also possible. I just terminate from this command and do the execution again. And see it's working. And I can also see here in the SSM plugin terminal window that the connection was accepted and the access to the private cluster has been established. Okay, so now what I can do is deploy my container image private. That's another version of my container image containing a different, displaying a different string. And let's just deploy that. But first we move to the correct folder and apply deployment YAML to the namespace private. Okay, that's done. Let's move over to Lens to see what's happening. Is Lens able to connect to that private EKS cluster? And yes, using the same connection, the same SSM channel, it's possible to connect to that cluster. Okay, if we check the overview here, we have several deployments. Okay, the one which we require is the hello world. And let's just go down here to find the service. I don't see the service which I want, but that's not a problem because I will get then that information from here with kubectl get svc from my private namespace. I'm interested in this external IP, which is not an IP, but that's the load balancer's address where our application will be able to connect to our private EKS cluster. So we don't want to make application connection to our cluster private. We want to leave them as public. So the load balancer will sit in a public subnet. That's okay, because it will be able to connect to our containers as the load balancer target. Okay, did I copy that one? Yes, I copied that. And let's just see what's happening with this web page. Okay, hello from EKS with private endpoint. So yeah, our developers from their own developer machine, from external networks, are connected to our private machines. Their session is logged. These session logs are encrypted, and session logs can be monitored in case of any unwanted commands are executed. We can see that the user which logs into that session manager, that bastion host, will have a local user. We can also see, so we can see person by person who and what did execute in our cluster without publishing our cluster endpoint to the internet. Okay, so that was my demonstration and my presentation for today. I would like to say thank you for the attention. And in case if you have any questions, you can find me on LinkedIn, on GitHub. You can find these examples which I was demonstrating to you on Saseki's Docker Hub, Docker Kubernetes Hello World, and AWS Secure EKS. The whole private EKS deployment will require multiple stacks. Of course, you will have to create the network, the IAM roles, the cluster, the node groups. Yeah, actually ECR is not required. I was just playing around with it. But the bastion host, that's also how to deploy that. all the stuff which you saw here in my demo can automatically be deployed. Okay, have fun playing around with it, and yeah, see you next time.